Hi everyone, this is Mohammed Hasnan. Today me, Amna and Umar will be discussing about unit testing. As we all know, in the very first session of this test automation carnival, Sohail Muhammad explained various type of testing. Today's session is somehow relevant to that as well. You can say it's a continuation to that, but it will be a bit inclined towards unit testing in JavaScript. So let's start now. Firstly, let me go through the agenda first, that what we will be discussing today. What is unit testing? What patterns we should avoid while writing unit testing? Then we will discuss a famous tool, Jest, supported by JavaScript, and then we will have a short term. So let's start the discussion. What is unit testing? In simple words, it is a process that verifies a small piece of code quickly in an isolated manner. Here, when you discuss unit testing, some questions come in your mind. Why do we unit test? Why do we write unit tests? Who writes unit tests? And what benefits do we achieve by writing unit tests? So firstly, we will look through why do we write unit tests. We do unit testing in order to measure the system's correctness. In simple words, how correctly a system works. When do we write unit tests? Normally, we see in our industry after completion of development cycle, we start writing unit tests. But there is some contradiction from multiple authors. They say that you have to like write in the dev before the dev closure. So yeah, there is a debate on that. Who writes unit test? Unit tests, as we all know, fall under the white box testing and are generally written by the software engineers developing the component. So what benefits we achieve? Let's suppose we identify a bug through one of our unit tests at early stages, like during deployment or right after the dev completion, but before any deployments. Then it's quite cheaper and easy to fix at this early stage rather than deploying a hotfix build on the production. So yeah, in the next slide we will see isolation. In the definition, I have said that unit test is a piece of code for testing another piece of code in an isolated fashion to measure the correctness of underlying functionality. So what do I mean by isolating manner? So let me explain that now. Isolation in terms of unit test means we can remove our dependencies by mocking so that we can test our system without any dependability. Yeah, the dependability are of two types. One is the stable and another is the unstable. So what is stable dependency? Stable dependency can be a built-in function by the native language or can be a function from third-party library. For example, here we can refer parseInt as a stable function, which is a very famous native JavaScript function. So yeah, the other is the unstable dependency. Unstable dependency can be a remote database or any third-party API or integration. From the first point, you see here the only difference between right and left diagram is that we removed the unstable dependency in the right diagram by simply mocking it. Mocks basically are the objects that we use to stimulate our response. In the second point, you can see a diagram elaborating how our systems look at high level and how unit test suites work around the system, which in turn is known as SUT, system under test. In this case, we will remove the dependent on the component. You can see DOC with the mocks. So next we will discuss coverage matrices. What is coverage matrices first of all? It is a ratio between the size of code base and test suites in which the direction they are moving. In simple words, you can say the ratio of line of codes covered by unit tests to total lines of code. All the libraries that we use to measure the coverage also follow the same rule that I mentioned. For instance, the libraries are Sonarland, NYC Istanbul, very famous in JavaScript. So yeah, so here questions come in your mind. Do coverage matrices measure the exact value about how a system works correctly? We will see it in the coming slides. So yeah, there are two types of matrices. One is the code coverage, another is the branch coverage. So yeah, the code coverage. You can, as you can see in the image, there's a formula for you. So according to the formula, lines of code covered over overall number of lines gives us the code coverage. There's an example for you. For example, in the given code below, you can see the overall number of lines are 5, uh, but the line of code covered are 4, which shows us 80% coverage has been achieved. For example, the one line which I am like I'm saying that yeah, it's not the part of the code coverage is the return true, because if the if works evaluates as a true, then it will. So yeah, for this session it will. So yeah, uh, it's 4 by 5, so it is 80% coverage. So next is the branch coverage. You can see in an image again, there's a formula for you. So according to the formula, branch traversed over the number of branches gives us the coverage matrices. So the question would be, what are the branch we traversed? So you can see an image at the right corner. For instance, in the same snippet, we have a length of 5 greater than 5. There are two independent paths. One path is for the length greater than 5, another is for the less than equal to 5. So the independent paths we have are 2. For instance, in this example, even in our snippet, it's 2. So like we are only testing the one end path. So it's 1 by 2 and it's 50% branch coverage. Next, we will see the multiple outcomes we can have while testing. For instance, you can see the snippet here. We are checking the condition if our length input is greater than 5, and even we are having an assignment to a variable which is out of which you can say it's global for its this function. So in this case, coverage matrices can have multiple outcomes. Let's say we do assignment to the variables, change state of class data members, etc. You can see the code branch coverage for this example as well. It's the code coverage is 100% and the branch coverage is 50. So next are the assertion-free test suites. As a assertion-free test suites. Amna, can you change the slide?
Stan, do I need to move one slide more?
Yeah, yeah. Yes, Amna. Can you hear me?
Yeah, I can.
Yeah. So in the next slide, we will discuss third-party lab functions. Yeah, yeah. You can see an image here. As you know, we have discussed earlier about the stable dependency. So let's just see how they impact the code matrices. For example, a very famous built-in function I told you before. It's the parseInt function. So in that stable dependencies, there are multiple scenarios. For instance, we pass null value, even a empty string, even a string with a five digit as a character, and even any string. So yeah, in the snippet you can see we are parsing value, a string value to an integer, and we are checking with an insert. So yeah, in this case, we can see the branch coverage is 100%, and even the outcomes is fully tested. But I can see no way, like if all the edge cases are tested in this or not. So yeah, while unit testing, we have to go through these edge cases scenarios. So in the next slide, I'll try to summarize. Now, like code matrices can be a good indicator how much significantly they are testing your code base. They as such don't depict how much they measure the correctness of your system. Even your code or branch coverage is 100%. It does not mean that you measure the 100% correctness of your system. So yeah, it can be a good indicator as well as a bad positive indicator, good negative or a bad positive. So next we will discuss the approach, or you can say how we can write the appropriate unit test. Yeah. For that we will like you can see the programmatic approach. Now let's see how we can write an approach, appropriate unit test cases. For that we will follow the programmatic approach. In this approach we see the two major questions. One is which part of the code to be selected, which means what should we test in order to verify the correctness of system. For instance, as in Confess, we deal with many enterprise applications. We all know that. So, like taking that in an enterprise application, the business logic layer is the most important, but the business logic is the most important for us. For example, in commerce website, our payment method has high importance. E-commerce website. For example, in e-commerce website, our payment method have high importance, and we should measure this component correctness as financial are the major goals for the business and more important than anything. So the second point is that whatever we select, we should verify that will it play an important role in our system. You can see a below diagram. Here we have few tests which have been written against few components, and the one that are above the red line have more worth towards the system, and the one which are below the line are less valuable to the system. So we can discard them in an initial phase. Yeah, in an initial phase. To summarize, we can say that we should write the tests first against those components which have high net value. And even as a software engineer, you are very familiar with the term functional programming. In this approach, we will write the code using functional programming. The code base should be written in a functional manner as well, and we should always write the code using multiple functions as it makes our code more reusable, and with the smaller number of lines that make our code more precise. Yes, now we will see the benefits of programmatic approach. First benefit is have a high change of catching regression error. So yeah, with the programmatic approach, we have high chance to encounter a regression error. As you all know, regression error occurs when a new feature is added to the system, and the what it affects with the previous functionality. For example, in the case of, for example, we can take an example. We have a system, and in this case, we will consider the payment method. The newly added functionality, such as pay through an Easy Pesa, does not save the transaction record in the system. Yeah. So yeah, we know that Easy Pesa API is working very well, and they are saving the record that they're in. But how about how to maintain our auto management system so that we will save the transaction in our system? So it is a kind of regression error. So next is the have a low chance of producing a false positive. I'll give a daily life example. For example, in this pandemic, like we see people are not suffering with corona, but they are like tested positive. So yeah, it can be a false alarm. Now let's see how that provides the fast feedback. While using this approach, you would be writing the code in programmatic manner, such as using functional approach, and this will give us a fast feedback as our code are loosely coupled. And last one is has low maintenance cost. Yeah, so I have discussed earlier the precise code thing. The lesser number of lines than the precise code. A precise code always have a less maintenance cost towards our system, and lesser the number of line of code, the lesser we have the maintenance cost. So yes, now we will discuss the three types of unit testing, styles of unit testing. One is the output verification, which is also known as functional style. Another is state verification, and then collaboration verification. Now, the output verification, or you can say the functional style. So as the name depicts, output verification. For instance, we have a function. You can also take the example which I have given, the snippet I have given, the calculate discount one. So yeah, in simple word, I can say you pass some input to a function and give some output, and you verify that output. Like it's very simple. So yeah, this type of style of testing would be output verification, and you have even seen the snippet. Yeah. So other is the state verification. As the name depicts again, we verify the state, multiple states of our, you can say, of our system or a piece of code. Yeah. So for example, we can take an example as a e-commerce website again. So yeah, we have a cart, and initially the cart is empty, and then we add an item in that cart. So yeah, we are having a change in our state of cart. Yeah. So you can see at the initial phase there was no item, and then there was an item. We can apply multiple asserts for that and check whether the item has been added in the cart or not. Yeah, even you can see a snippet here, like you can see it out of menu, we pass an object in that, and we have a time data array, and we push in that, and otherwise, and then we check the assert for the result, and is it that appropriate for us or not. Then other is the collaboration style. As the name again, as the name depicts again. So yeah, multiple services on the system interact and they collaborate with each other, and we can like verify them together. So yeah, for instance, there are, for example, you can see we have a order class, a service class, and a mock class, and we instantiate them, and then we invoke the service class method submit, and pass the order and the mock instantiation in them, and then we are achieving that, we are achieving the order to, like, we are achieving to save the order in our database. So yeah, we can apply multiple servers to check even our order instances correctly instantiated or not, even our service is returning after returning some response after saving the database, it is the correct or not, like it can be in multiple ways. So yeah, this is all from my side. Next, Amna will uh, give you a brief introduction to how to avoid anti-persons. So anyone have question regarding to my portions, and so he or he can ask. Okay, fine, I guess we can move towards the next section. So Amna, over to you. Thank you.
Thank you, Snan. Hi everyone, myself Amna, and I will be explaining, different unit testing anti-patterns which are commonly used and overlooked while performing unit testing. Before I start, we all must be very clear why to avoid the anti-patterns. Well, the answer lies into the next question. What does it mean when we say something is an anti-pattern? An anti-pattern is a response to a recurring problem which is usually ineffective and have highly counterproductive risks involved. So we must avoid the anti-patterns. So I will be explaining different scenarios or situations where these anti-patterns are used, and I will be showing you guys how to avoid them and what are the best practices or solutions in those scenarios. So let's start. Here I have listed some of the anti-patterns I will be explaining: exposing implementation details for the purpose of unit testing, leaking domain knowledge to your unit test, adding pollution to your code, violation of single responsibility principle, and non-determinism in tests. I will be explaining these in detail with the help of examples in next slides. One of the most violated anti-pattern, or you can say a set of anti-patterns, is exposing implementation details in order to enable unit testing. Here I have listed two examples here: making your private methods public and exposing straight getters. You might have heard the question, how to unit test your private methods? Well, the answer to this question is you should not do this. If you make your private methods public, this for the sole purpose of unit testing, it means you are exposing your implementation details. So whenever we do unit testing, we should always aim and verify public API of the class. The public API is defined by its usage pattern. If a method or class addresses an immediate goal of the client, then it's a good subject for unit testing. Private methods don't belong to the class public API. So the only way to test private methods is through the public API, which invokes those methods. If you see that some of the private methods are very complex and leaving them untested has high risk involved, it means that you need to extend its inner working into a separate class and test that class instead. Here is an example. You can see the order class has a public method, generate description, which returns total number of products and the total price. The method which calculates the total price is private, and at the same time it contains business logic, quite a complex business logic, which needs to be tested thoroughly. So one way here could be to make this method public, then it will be available in unit test and we can perform the unit testing, but that's an anti-pattern. So solution here would be to instead of making these public methods public, we can introduce a separate price calculator class, and then we can use this class to perform our functionality, and now this class can be tested separately. One may argue here that this price calculator class is only being used by the order class and it doesn't belong to the domain models API. Well, to explain that, it does belong to domain models API, but in this hierarchy, you can see the price calculator comes down in this hierarchy, and it's it is being exposed to its outside world, that is the order class. So we will be testing that. Another anti-pattern that is often encountered is exposing state getters for satisfying a test. Here is an example. You can see the customer class has a private status field which determines what discount he or she will get. The regulars don't get any, while the preferred gets 5% of the discount. And the promote method transfers customer status from regular to preferred. All right. So if we want to test the promote method, how should we do that? Because the status field is private, so it's not available in the test. So there is no direct way for us to see if we call the promote method, the customer is transitions successfully from status regular to preferred. So an obvious way to overcome this problem is to make that field status field public or expose some state getters. But that's an anti-pattern. The status field is not observable from the outside world and thus does not belong to the class public API. Exposing it would mean we are exposing the implementation details. So what is the solution? It seems here that the client don't care about the status field. Otherwise, that has been made public. What they do care about is the discount the customer is entitled to. So that's what we should aim at verify and test as well. We can check a newly created customer has no discount. That would be our first unit test. We can verify once we call the promote method, the discount becomes 5%. We can also check the additional promotions don't increase the discount. This way, we are binding our test to the observable behavior only and not to the implementation details. Another anti-pattern is to duplicate the implementation of the system under test. Here is a very simple example. This is a calculator class. It has a method to add two numbers and then return the value. And in our unit test, we have value 1, value 2. We are adding those values and getting the expected result. Then we are comparing it against the add method of calculator. We can also prepare our test data, and then we can perform the unit testing. But here you can see value 1 plus value 2. This is the leaking knowledge, because this is the implementation detail of our actual code, the add method. So that's an anti-pattern. So what should be the solution here? Here are two solutions. You can either do the property-based testing. The property-based testing is not in the scope of today's session. And the next is you can pre-calculate the results and hard code them into your unit test. So we can, here you can see we have pre-calculated the results and hard coded, and then we are comparing it against the add method. Another anti-pattern which is often encountered is you add your additional code to your main code base just to enable unit testing. Examples would be adding new methods to your existing classes and bringing in various types of switchers. Let's see an example. This is often the case. We need some loggers in our applications whenever we are building some system. We need to log different error messages and different informations, and it is often the case that while we're performing the unit testing, we don't want to log anything. So here you can see in the log method, we are writing if else or different kind of switchers just to check if the environment is testing environment, then return and do nothing. But that's an anti-pattern. So the solution here would be to introduce an interface, iLogger interface, and implement two loggers, one for production and the fake logger for the testing purposes. And you can see the controller class is using the logger instance. It is often the case that the system under the test requires some external dependencies, and that dependency cannot be easily resolved because it refers to the external world. Here you can see the customer controller class requires an instance of statistics calculator class, which can then be used to get the statistics information. However, in order to calculate the statistics, it depends on third-party service to get the recent deliveries. So if we want to test this, it's because it depends on the third party service, so it's not easily tested. One solution here would be to make this decent deliveries method virtual, so that we can override it into our unit test with the help of mock, but that's an anti-pattern. The fact that you need to substitute not an entire class but only a part of it is a sign that it violates a single responsibility principle here. If you look closely at the statistics calculator class, it has two distinct operations to perform: get the recent deliveries with the help of third-party service, and then perform some calculations on the results. So what we can do is we can split the statistics calculator into two classes. The delivery gateway class that will interact with the third party service, and then the statistics calculator which will perform the actual calculations here. So this is our final code. Now the customer calculator class has two instances, the calculator one and the delivery gateway class. So it will get the recent deliveries from the third party, and then it will feed those deliveries to the calculator class, and that will perform the actual results. Another anti-pattern which is faced is non-determinism in tests. So non-determinism means you have some flickering tests. Flickering tests are those tests which pass most of the time but fails once in a while. And if you run them again, they will turn green again. Non-determinism can have devastating result on your entire test suite, and the test suite is no longer perceived as a reliable feedback. It usually happens in asynchronous code, like in this example here. You can see the customer service, we're creating a new object of customer service class, and the service done some job that needs some time to complete, and then we can verify the results. So there is no way for us to know what time this job will take. So we are randomly giving it some time, thread.sleep, so that after that we can verify the results. So this kind of test can pass most of the time, but if the job takes more time than the stated here, it may fail. So I would like to say, to avoid these kind of problems, you should try to avoid the asynchronous code, and you should try to only test the complex code. Even if you cannot do that, what you can do is you can return some task from the this customer service, and then you can wait on that task, then you can verify the effects of the job. Another problem we face is whenever we work with dates. So here, the customer service class, we are creating a new object, and then we are comparing the date created with the date time now. So it may pass if it's not taking time to create a customer, but if the system is slow or it takes some time, this will fail. The solution to this problem is you can introduce a new class, system datetime, and you can see here it has init method which is taking the datetime function, and then datetime now we can return the date. So we can introduce two instances here for the production. We can initialize it with the datetime.now, and for the unit testing purposes we can initialize it with the hard-coded date, so that it will return the same date to us. So that's it from my part. If you guys have any questions, you can ask.
So guys, just a quick comment that asking you questions will create engagement in the session, and you're going to get a gift. So please ask questions. I guess we can move forward.
Okay. So next, Umar will briefly explain some of the unit testing frameworks in JavaScript, and he will be explaining one of them in detail. So over to Umar. So I can stop sharing your Umar. You can share.
Yes, thank you, Amna. So Assalamu alaikum and good morning. Umar here, and I'll be going through some popular unit testing frameworks for JavaScript. Just let me share my screen first.
आपकी फोटो बहुत अच्छी है यार.
Thank you. So yeah. So yeah, I'll be going through some popular unit testing frameworks first, and then later on I'll be talking about Jest, which is our most popular framework, and then I'll be presenting a demo as well. So moving forward, so there are some popular frameworks like Jasmine, which basically mimics user behavior, mostly used on the front end. And then we have QUnit, which is mostly preferred by jQuery developers, also used on front end. And a popular framework, Mocha.js for both front end and back end. And then we have Sinan, which is just a complementary tool we can use with other unit testing frameworks for mocking purposes. Then comes Jest, which is most popular framework and is highly maintained by Facebook. So React.js and React Native are also by Facebook, and most of you know this technology by now. So it comes preloaded with Jest, not just React. It covers Node.js, Vue.js, Angular, and other people-based projects as well. And then comes Karma, so which is also a popular framework when it comes to integration with CI/CD engines on an advanced level. Then we have Chai, and there are many more frameworks as well. So moving forward with the Jest unit testing framework. So there are tons of features that Jest provides, and this is just the content. I'll be going through each incoming slides. So moving forward, first off, so setting up Jest is pretty simple. You put this command on your terminal and it gets get the Jest installed, and you simply have to add these scripts in your package.json file, and that's pretty much it. And then Jest does not require a configuration on JavaScript project, but when there are some changes required, there is always a way to configure Jest. So you just go on and add the configuration in package.json file, and it automatically detects from there. Also, Jest can also go through the Babel RC file and to instantiate its configuration. So this is the folder this is how the file structure and the folder structure is in the Jest. So Jest automatically picks up the tests that basically reside in this directory with this name, or if you specify an extension of the file with .test.js or .spec.js, it automatically identifies those file as test files and run those whenever you run the test. So Jest itself uses Jasmine as a test runner. That is why it's very familiar syntax. So moving forward.
Omar, can I ask
yes.
a question?
Yes, sure.
You told something about Babel. So how is it related to Jest, and how is it being used here? So I didn't get that. Yes,
so,
I didn't.
So Babel basically, for example, if you are running a project that is basically a React.js project, for running a unit test, you might require some additional dependencies. So this Babel basically contains all of the presets for in case of you are using React, and this just basically look into the Babel file and identifies those presets, and based on which it can run the test.
Babel is basically what I read and what I know is Babel is basically a JavaScript transpiler that is mainly used to convert ECMAScript into, let's suppose, ES6 into a backward compatibility version. So is it something like that? Is it the same thing or something else? Babel, yes.
Yeah, Babel, you're definitely correct. But the jest is basically run in a separate environment, and it it's not totally dependent on Babel RC, but it do take advantage of it by, checking out all of the dependencies that the project is using. So yeah, am I clear? No? Should I move forward?
Yeah, sure.
Thank you. So then we have a convenient test status reporter, which shows you real-time progress of tests executing on your terminal. And moving forward, so Jest works with any compiled to JavaScript language. Like we have TypeScript, and we are just few configurations away, and then it's up and running on TypeScript project. So this kind of configuration it normally requires, and that's pretty much it. Then comes the testing of asynchronous code in JavaScript. So I'll be going through these examples in demo as well. So I'll be skipping it for now. Yeah. So then we have the snapshot testing. So snapshot testing is basically writing test is simple. Running a test, I'm using a JavaScript. I'm using React.js as an example. So it saves a snapshot of the component when it runs for the first time. And later on, when you run the test again, basically it compares the new snapshot with the older one and notifies you about the changes based on which you can detect and identify which changes you need and which you don't, and update your snapshot accordingly. So yes, I'll be going through these as well on the demo. So snapshot basically covers most of the React components, React Native components, objects, and CLI outputs. And change in time can also be recorded by snapshots, and also GraphQL queries and DB shapes and many more. So there are some pitfalls as well that user needs to be very careful while updating or validating their snapshots. And updating snapshot is not super convenient yet. Yeah. So it is fast and efficient, and it takes advantage of all of the available cores. Tests get cached and automatically runs error test first. And they are sandboxed, so which means they run parallel. So moving forward, so Jest gives us very meaningful error messages. Also, we have a built-in coverage reporter. So this is the built-in coverage report in the Jest. So this is the built-in coverage reporter. And in Jest, we have 4 different coverages like statement, branches, functions, and lines. So it also gives you the lines which are not covered. So in this case, all of the lines are covered and it's not shown. So we have 2 different kind of mocking in Jest. One is manual mocking. So this is the presentation of manual mocking here. And then the other is functional mocking. So yeah, so for the mocking purposes, basically wherever basically the file that you need to test resides, you'll have to create a directory with mocks with the same folder name, like as it's shown on this slide. So this will basically whenever you try, whenever you are running the test, it will automatically pick up the mock files that basically reside under this folder. So it should be on the same path where your file actually resides, and it should be of the same name as well. So yeah, so using the mock is pretty simple. You just call jest.mock and you just require the file that you are actually trying to mock. So that's pretty much it. So this is like you can implement the mocks on the on like without creating any file. So, and also you have the ability to mock your functions that you are passing on to the as a parameters, or maybe passing those as like if the particular test you are writing is dependent on functions which need to be marked. So and then so expect is a very popular measure library which is used by Jest, and then we have the watch mode in Jest, which is fast and can run tests related to changed files, and we can interrupt while the test is running and modify the watch mode as well. So also you can tell it the file name pattern, so it only run those matching file names tests, and it also it's also very test driven development friendly. So then we have some editors integrations as well. Like in case of VS Code, we have this extension VS Code. Just we can simply plug it in, and that's pretty much it. It will automatically start showing you test results on the code itself. So yeah, moving on to the demo now. So let me show you the application that I basically created for this demo purpose. So this is just a simple to-do list. I just basically populated it with some grocery items. So for example, I just add an item and it simply loads, and basically all of these items are added to the local storage of the browser. I'm not using any API call right now, but there is some asynchronous code in it, and I'll be going through asynchronous testing as well. So this is the project itself. So first off, I'll be showing the folder and file hierarchy that I'm following. So Jest basically recognize all of the tests with these extensions, and also the if we go to spec.js, they are automatically recognized by Jest. So whenever I try to run a test, it will automatically detect this. So first, I'll be going to show you a simple test. So so this is the file that I have written. So in Jest, we can this is our, for example, this is the function we have, a sum function, and it requires 2 parameters, and it's just as simple as that. You just give it the parameters and what you actually expect, and you just match it to the value that you are actually expecting, and that's pretty much it. And you see a tick with this. So this basically is the extension that I'm using, the extension I actually referred to in the to you guys in the previous slide. So yeah, I'll be going into detail later on. So then we have the asynchronous code. So I have written some API endpoints. So these are basically like promises, and I return some data after a timeout of 1 second. So we have like get list and then add item and then remove item. These are few methods, 3 methods that I'm using right now. And if I go to the test file of this, so I'm using this spec.js file for this case. And we have, I have created all of the tests in different like ways that we can write tests for asynchronous code. So for the first one, I'm like using this async await method to test to test the get list method, and for the second one, I am using this dot then, like we are calling a promise. We can also go through this method, and then we have like there is a done parameter that we get from the test, and we just simply call that whenever we want to end the test, or we can call done.fail simply when the test basically fails. So yeah. And then comes the snapshot just test. So
Well, I have a question here.
yes.
So first thing is that jest is working in case of promises, but does it support observables, as observables are returning stream of values, and how does it react in that case? How does it behave in case of observables in JavaScript?
Yeah, Abdul, I'll have to go through that. I'm not sure what you're actually talking about. So yeah, we can discuss it on later on.
Okay, sure.
So then comes the snapshot testing. So I have, this is basically my whole application component. I have written a test for it, and it basically covers all of the scenarios that this component covers. So this is the test file for this component, and yeah. So as you can see, this is the way how this component looks. So this is the representation of that component that I have written tests for. So 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 it requires some local storage. So in this case, I actually mocked the local storage, and I'm using module for this purpose. And this is the way I am actually clearing the, so what happens is when I go to my package JSON, so so yeah, setting up test. So this is the way I'm actually mocking the local storage. So local storage does not exist in this environment. We'll have to mock it anyway. So that is why it is working in the jest environment. So this is the setup test file. It always executes whenever each test start running. So yeah, moving forward with the app.test file. So local storage gets cleared before all of the tests, and also I'm setting some list items. Already there are item 1 and item 2 in it. So when I initially mount the component, so I'm just matching the snapshot. So snapshot test, what it does is it creates a snapshot. Like this is the snapshot of the whole app component, right? So in case, like for example, I go ahead and change the element. So initially my test was passed with the items, with like 2 items already in there. So if I remove one item and I try to run the test again, so it will basically, so this is the watch mode actually. It automatically detected and it ran the test. So this is the list item that is shown. So there are 4 list items for now. And if we imagine this over here, so there should be like item 1 and item 2 here. So it was expecting both of the items, but it only got the item 1. So it actually recognized this and throw in an error. So yeah. And then I'm actually like matching the number of items we have. So it failed here. And if I comment this line, it will move on to this line. And it was expecting 2 items, but it got instead 1 item in it. So that is how the testing is working. So you can see the line underlined here. It is basically running the test with the VS Code Jest extension as well. And I don't have to like run the watch mode parallelly to test my files. So yeah. Then
I have
I'm
a
actually
question here. I'm sorry, I'm interrupting, but I have a question here regarding the snapshot test that we ran just above that you commented right now. For example, there is an other application that we want to do this sort of snapshot testing. Would we have to keep if you can open app.test.js.snap, then I think we can have.
yes.
Yeah, this one. So from my understanding, this was manually kept here, right? So basically we said that this should be what our application should look like, and we copied it here, right? Or it was
No.
automatic. Okay.
No. So I missed one thing. So basically, snapshot is automatically generated whenever you run the test for the first time.
Okay.
Right? When you run the test for the second time, it basically compares the previous snapshot that is already existing here with the new one and tell you the differences.
So the purpose here is that, after, let's say I make some changes to my UI or anywhere in the application that I was testing last time, I could see where those differences occurred. Is that right?
Yes, that is correct. So it basically identifies even a single change, even a styling change in your code. So it will notify you that this is the change I'm getting. And if you are satisfied with the change, you can go ahead and update your snapshot. It just requires another flag while running a test, and it will update your snapshot. Yeah.
Okay, so it's not exactly a test where you can assert something.